Hello everyone. Today we're going to learn how the fundamental theorem of calculus, or the FTC, and particle motion are related. So here are some things that you need to keep in mind. Whenever you integrate velocity, we know that this is going to give you the position function. Particularly, it'll be P of B minus P of A in terms of position. Now this P of B minus P of A should look familiar as net distance. If your velocity never changes signs, then it also would represent your total distance. However, when we integrate the absolute value of velocity, then this is going to equal to the total distance, whether or not velocity changes signs. So let's build up on these three things that to keep in mind. Let's look at a sample question relating integration and velocity. If the integral of -2 to 1 of v of t dt is equal to 5, and the integral from 5 to 1 of v of t dt is equal to -6, and p of -2 is equal to 3, what is the value of p of 5? Now keep in mind here, there's one thing that I noticed, which is my limits of integration here are reversed. So I'm going to flip them back. So this will be -1 to 5 of v of t dt, which is equal to -6. If I divide negative to both sides to get rid of this here, then that would mean that the integral from 1 to 5 of v of t dt is equal to 6. Now what we're trying to find here, we have p of -2 is equal to 3, and we're trying to find p of 5. This is something that we've done before, and we know that these values here are going to be my limits of integration, since in order to find the function value for p, I would need to integrate v, which is what I have here. So I'm going to set up my integral. This is going to be from -2, because this is this value, to 5 of v of t dt. And this is supposed to equal to my position function evaluated from -2 to 5. To get this number here, notice how it goes from -2 to 5. And these two integrals that I have from -2 to 1, and then I have 1 to 5, which if I add them together, it gives me from -2 to 5. So that's what I'm going to do. I'm going to add my integrals -2 to 1 of v of t dt plus the integral from 1 to 5 of v of t dt, that's this side of my equation, is going to equal to, and if I apply my FTC here, this is p of 5 minus p of -2. Now we have these values. From -2 to 1 is 5, plus from 1 to 5, which is what I rewrote here, is 6. And that's going to equal to p of 5 minus p of -2, which is 3. 5 plus 6 is 11. And this is going to allow me now to solve for p of 5. So I'm going to add 3 to both sides. So the position of the particle at t is equal to 5 is going to equal to 14. Let's look at another sample question. The velocity of a particle that is moving along the x-axis is given by the function v of t is equal to 3t squared plus 6. If the position of the particle at t is equal to 4 is 72, what is the position when t is equal to 2? So what this is telling me is that p of 4 is equal to 72. And what I'm trying to find here is the position when t is equal to 2, so I'm looking for p of 2. So we're going to set up an integral that will allow me to find for these function values. So my integral from 2 to 4, because those are the t values that I have, of v of t is going to equal to p of t evaluated from 2 to 4. Now, over here, we learned how to do this if we're given some values or if we're given a graph. But here, I don't have that, but I do have the equation. So I'm going to substitute v of t with the equation that's given. So I'm going to evaluate the integral from 2 to 4 of 3t squared plus 6 dt. And this is going to equal to p of 4 minus p of 2. Now this I'm going to have to actually work out what this number is. If I integrate 3t squared, that's going to be 3t to the third over 3. So the 3's would cancel, plus 6t. And I'm going to evaluate that from 2 to 4. And on the other side, I have p of 4, which is 72, minus p of 2. On this side, we're going to actually get what that number is equal to. So I'm going to plug in the 4. So 4 to the third is 64, plus 6 times 4, which is 24, minus, now I'm going to plug in the 2. 2 to the third is 8, plus 2 times 6 is 12. And that equals to 72 minus p of 2. 64 plus 24 is 88, minus 8 plus 12, which is 20. 88 minus 20 is 68, and that's going to equal to 72 minus p of 2. If I subtract 72 from both sides, I get now that 68 minus 72 is negative 4, is going to equal to negative p of 2. Divide both sides by negative 1, we get that p of 2 is equal to 4. So this is just building off of something that we did from our previous lessons. Now let's look at part B. What is the total distance the particle travels on the interval 0 to 7? Now, to get total distance, keep in mind notation. Total distance is the integral from 0 to 7 of the absolute value of v of t dt. Now, we don't know how to integrate absolute value, and that's okay. There's a way of working around that. What we're first going to do is check if the particle changes direction, because if it does, then I would need to, think about it if you had a graph. If it changes direction, then that means that you'll have some of your graph above the x-axis for when it's going to the right, and below the x-axis for when it's going to the left. But because this is total distance, we would need to add those areas regardless of their signs. So that's why we need to check if it changes signs. So I'm going to take my velocity equation, which is 3t squared plus 6, and I'm going to make it equal to 0. Since that's how we get if it changes signs, is if it equals to 0, and then we do our number line to check. So I'm going to subtract 6. So we get 3t squared is equal to negative 6. Divide 3. We get t squared is equal to negative 2. And then square root. But here we get an imaginary number. So what that means is that v of t is never going to equal to 0. And if it never equals to 0, that means that it never crosses the x-axis and your velocity will never change signs. So it's always going to go in one direction. Therefore, my total distance is going to equal to my net distance. And we find net distance by integrating from the interval 0 to 7 of v of t dt. Now we already integrated v of t. We got that it is t cubed plus 6t, but we're now just going to evaluate from 0 to 7. Plug in the 7. 7 to the third is 343. plus 6 times 7 is 42. Minus, when I plug in 0, everything would be 0. So we get here 343 plus 42 is 385. And if we had units, we would include the units, which would just be either feet or meters or inches, whatever the case may be, since this is distance. And this would be my answer. Let's try a couple more. The velocity of a particle that is moving along the x-axis is given by the function v of t is equal to t squared minus 8t plus 12. If the position of the particle at t is equal to 6 is 1, what is the position when t is equal to 3? So this is very similar to the question that we did previously. What this is telling me is that p of 6 is equal to 1. And what we're looking for is when p is the value of p of 3. This is going to tell me what my limits of integration are, the 3 to 6. So I'm going to integrate my velocity, because that gives me position, from 3 to 6 of v of t, which v of t is this here. So t squared minus 8t plus 12 dt. And that's going to equal to my position function evaluated from 3 to 6. Now I'm going to actually have to integrate this and apply the FTC so that I can get this numerical answer. So this is going to be t to the third over 3 minus 8t squared over 2, which is 4t squared, plus 12t. I'm going to evaluate that from 3 to 6, and that's going to equal to p of 6 minus p of 3. Now let's work out this side here. If I plug in the 6, 6 to the third is 216. And 216 divided by 3, because I'm plugging it in here, is 72. Minus 6 squared is 36, and 36 times 4 is 144, plus 6 times 12 is 72. Now I'm going to subtract and plug in the 3. 3 to the third is 27, and 27 divided by 3 is 9, minus 3 squared is 9 times 4 is 36, plus 12 times 3 is 36. And this is going to equal to p of 6, which I was told is 1, minus p of 3. Now let's work out over here. 72 minus 144 is negative 72. Plus 72 is 0. Minus 9. And then here this negative 36 will cancel with this positive 36. So 0 minus 9. Which this side here is negative 9 is equal to 1 minus p of 3. If I subtract 1, I get negative 10 is equal to negative p of 3. Divide both sides by negative 1. I get that p of 3 is equal to 10. For part B, what is the total distance the particle travels on the interval 1 to 5? So first, what this means is I'm going to integrate 1 to 5, the total distance. So that's the absolute value of v of t dt. The first thing I need to check is if my particle changes direction. So I have this here outlined for you. First, determine the value of t where velocity changes signs. And that is when v of t is equal to 0. And we're going to check that. So my v of t, which is t squared minus 8t plus 12, equals 0. Since this is a quadratic, I can factor. This is t minus 6 and t minus 2. since negative 6 times negative 2 is positive 12, and negative 6 minus 2 gives me negative 8. So I have two critical numbers, which are at t is equal to 6 and 2. The 6 is outside of this interval, so I don't need that one. My only critical number now is 2. So I'm going to create my number line and verify that my velocity does indeed change signs. If I plug in 0, 0 minus 6 is negative, 0 minus 2 is negative, so negative and negative make a positive. And if I plug in 3, 3 minus 6 is negative, 3 minus 2 is positive, so a positive and a negative remain negative. So as you can see, it does change signs. So what that means for total distance is that we need to find the distance here. Since this is positive, that means that that particular distance is going to be above the x-axis, and then I'm going to add the absolute value of the distance after that. So we're going, and here I have that, the integral from a to c of v of t dt, where c is where it changes direction, plus the absolute value of the integral from c to b, which is the endpoint of v of t. So let's set that up. We're going to do the integral from 1 to 2 of v of t dt, plus the integral from 2 to 5, absolute value of that, of v of t dt. Since one of these distances are going to be negative, that's why we have the absolute value there. We've already integrated v of t. We did that over here. This is my function. So it's t to the third over 3 minus 4t squared plus 12t. And this one we're going to evaluate from 1 to 2, absolute value of that, plus the absolute value of t to the third over 3 minus 4t squared plus 12t, evaluated from 2 to 5. Plug in the 2. We get here 2 to the third is 8 over 3 minus 2 squared is 4 times 4 is 16 plus 12 times 2 is 24 plus, now, oh, nope, not yet. I only plugged in 2. I need to plug in the 1 now. So minus, when I plug in 1, this will be 1 to the third minus 4 plus 12 plus, now I'm going to do this side. 5 to the third is 125 over 3 minus 5 squared is 25 times 4 is 100 plus 12 times 5 is 60 minus, now I'm going to plug in the 2. 2 to the third is 8 over 3 minus 16 plus 24. Okay. I'm going to erase some of the top here so that we can continue working up here. Okay. So I'm going to continue over here. Let's work out what these numbers are. We have the absolute value of 8 over 3, negative 16 plus 24 is 8. So this would be plus 8 minus 1/3, and negative 4 plus 12 is 8. So plus 8. Plus, now I'm going to go to the other side. We have the 125 over 3, negative 100 plus 60 is negative 40, minus 8 over 3, and then negative 16 plus 24 is the plus 8. All right, I'm going to distribute this negative and this negative here. So we get absolute value 8 over 3 plus 8 minus 1 over 3 minus 8 plus 125 over 3 minus 40 minus 8 over 3 minus 8. This 8 and this 8 will cancel. So 8 over 3 minus 1/3 is 7 over 3. It's already positive, so I can remove the absolute value bars. Plus 125 over 3 minus 8 over 3 is 117 over 3. And negative 40 minus 8 is negative 48. We're going to actually get what this value is, so I'm going to rewrite 48 with a denominator of 3. So this is 7 over 3 plus 117 over 3 minus, now if I put this over 3, I'd have to multiply this by 3. And 48 times 3 is 144 over 3. 7 over 3 plus absolute value of 117 minus 144 over 3 is negative 27 over 3. Which, yes, I can divide this, but I'm going to have to add it with this 7 over 3, so I'm not going to do that quite yet because I would need a common denominator anyway. So now at this point, since I'm left with only one number inside of the absolute value, I can remove it and make it positive. So this is 7 over 3 plus 27 over 3. 7 plus 27 is 34 over 3. So this would be my total distance. So bottom line, when you're trying to find total distance, make sure you first check when velocity changes signs, and then you're going to get the absolute value of the integral of both from where it changes and add them together. Keep in mind that this is very similar to what we got for total distance when we were learning derivatives. Total distance before was defined as the absolute value of P of A minus P of C plus the absolute value of P of C minus P of B. So the distance between the starting point and where it changes plus where it changed, the distance between from where it changes to the end point, which is exactly what this is. If you apply the fundamental theorem, this would be P of C minus P of A plus P of B minus P of C. It's the same thing, just a different order, but it doesn't matter because of the absolute value bars. With all your numbers would end up positive anyway. So just keep that in mind as well. Now let's have a look at how we can relate our particle motion and integration when it comes to graphs. The graph of the velocity measured in feet per second of a particle along the x-axis is pictured below. So this is the velocity graph. So I'm just going to label this so I don't forget what I'm looking at. The position P of t of the particle at t is equal to 8 is 12. So what that's telling me is that P of 8 is equal to 12. Use the graph of V of t to answer the following questions. Part A. What is the position of the particle at t is equal to 3? So what I'm trying to solve for is P of 3. This means I'm going to have to set up an integral because since I'm given velocity and I want to find position, I got to go backwards. This is one of my limits of integration, and since this is the one that's given, this is my other limit of integration. So my integral is going to be from 3 to 8 of V of t dt, and that's going to equal to my position function evaluated from 3 to 8. Now this is a little bit more familiar because now we have a graph instead, which we've done this before. Since this is V of t and I'm trying to integrate that, that means I need the the area from 3 to 8. So what I have here is I have a trapezoid and then a triangle. So let's find those areas. So first, for the area of this trapezoid, it is 1/2 times the height, which is parallel to the bases, so that's 1, 2, 3, 4, 5, times base 1 plus base 2, which is 1 plus 3, which is 4. Since the triangle is below the x-axis, I'm going to subtract 1/2, the base, which is 2, and the height, which is also 2. And that's going to equal to P of 8 minus P of 3. Half of 5 times 4, that's half of 20, so 10, minus half of 2, this will cancel, so 2 is equal to P of 8, which was given to be 12, minus P of 3. 10 minus 2 is 8, equals 12 minus P of 3. Subtract the 12. We get that negative 4 is equal to negative P of 3. Divide both sides by negative 1. And we get P of 3 is equal to 4. For the next question, what is the acceleration when t is equal to 5? Now, acceleration is the derivative of velocity. So now, instead of going backwards, we're going to go forward by taking the derivative. If I want the acceleration, so a of 5, since I don't have an equation, but I do have the graph, I see that a of 5 is right here. So I'm going to have to find the slope of that line. Now you can use your slope formula, right? This would be v of 4, so the point to the left, minus v of 6, the point to the right, all over 4 minus 6. V of 4 is 5, minus v of 6 is 0, over 4 minus 6, which is negative 2. And this is going to equal to 5 over negative 2. So my acceleration at 5 is going to equal to negative 5 over 2, and then our units here would be in meters, or sorry, in feet per second squared. Oh, and by the way, here my position, this would be 4 feet. Now for the total distance. What is the total distance a particle travels over the entire interval? So that means that we're looking at the entire graph, not just that section. So this is going to equal to the absolute value of to the integral of 0 to 10 of the absolute value of v of t dt. So what that means is that I need to split it up. You can see that here my v of t is equal to 0. So at t is equal to 6, my particle changes direction from going to the right to going left. So I would need to do the absolute value of the integral from 0 to 6 of v of t dt plus the absolute value of the integral from 6 to 10 of v of t dt. So basically, we're going to take the area for 0 to 6, and keep that in absolute value, so that's 1/2. Now the height of this trapezoid is still 5, and my bases are going to be 2 plus 6, plus the absolute value of this triangle here, which, since it's below the x-axis, we normally write that it's negative, and that'll be 1/2 the base, which is 1, 2, 3, 4, times the height, which is 2. And of course, I still kept it negative here because I'm going through like the rules. It is below the x-axis, so it should be negative, but because this is total distance, that's why I have the absolute value, and we're going to end up taking the positive number anyway. So here, 2 plus 6 is 8 times 5 is 40, divided by 2 is 20. And it's already positive, so I can remove the absolute value. Plus, here this 1/2 and this 2 will cancel, and we're left with -4. But because it's an absolute value, we're going to make it +4. And 20 plus 4 is 24. And since this is distance, my units would be feet. Now let's look at some charts. The table below shows values of velocity in meters per second of a particle moving along the x-axis at selected values of time in t seconds. So here we have our chart. Looking at this first question, it says, what does the value of the integral from 0 to 18 of v of t dt represent, and what units would be used? Since we are integrating velocity, that means that our answer would be position if it was an indefinite integral, meaning it would not have these numbers here. But because we're given an interval, when we apply the FTC, it would be p of 18 minus p of 0, which what that means is that this is net distance. Due to the notation, since net distance is the integral velocity, whereas total distance has the absolute value bars. So here this would be net distance, and my units would be in meters. Here we're not being asked to calculate what this would be, just what would it represent. For part B, would the net distance the particle travels equal to the total distance, and give a reason to your answer. So the only way of knowing whether net distance is going to equal to total distance would be if velocity changes signs, then it would not equal. But if velocity does not change signs, meaning it doesn't change direction, the particle doesn't change direction, then net distance would equal to total distance. If I look at all of these values in my chart, we notice that all of these velocity values are positive. So that means that the particle is only moving to the right over this entire interval, meaning the particle does not change direction. So here we would say that net distance would equal to total distance. And the reason would be because the particle does not change direction. And I know that the particle is not changing direction because, I'm just adding this in as another side note, because velocity does not change signs. You don't need both statements. This is your main one, the particle does not change direction. I'm just wanted to, point out that that's how we know that the particle does not change direction. For part C, on what interval is the speed of the particle decreasing, and justify. So keep in mind, when we're doing these questions, and even though we've already finished our derivatives unit and we're now on integration, derivatives still come back a lot because they are all mixed in together along with these questions. So we do need to remember the things that we learned from derivatives. In order to know if the speed of the particle is increasing or decreasing, we would need to compare the signs of velocity and acceleration. So how do we know the sign of acceleration? If velocity is increasing, then that means that acceleration is positive. If velocity is decreasing, then that means that acceleration is negative, since acceleration is the first derivative of velocity. So from 2.3 to 2.7, we see here that this is increasing, meaning that acceleration is positive. From 2.7 to 2.0, it's decreasing, and then continues to decrease all the way from 2.7, it's decreasing, 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 but then here it's increasing. So on this entire time, A of t is negative. And then from here onward, it's increasing because it goes from 1 to 1.7 to 2.1. So A of t is positive. So now when the speed is decreasing, v of t and a of t have to be different signs. V of t from the chart is always positive. So we want the interval where a of t is negative, which would be starting here at the 3 and ending here at 12. So the interval would be from 3 to 12, and we would say because v of t and a of t are different signs. For this last question, find the average acceleration of the particle on the interval 3 to 9. So average acceleration, that is the slope of your secant line of the velocity. Since you're given these two numbers, that means that we're going to use those two as my values of t. So we're going to do v of 3 minus v of 9 over 3 minus 9. V of 3 is 2.7 minus v of 9, which is 1.3, over 3 minus 9, which is negative 6. Now 2.7 minus 1.3 is 1.4. And 1.4 divided by negative 6 is negative 0.2333. And since this is acceleration, my units here would be meters per second squared. Let's look at our last problem. Now we're going to put it all together using this graph. A car is traveling on a straight road with velocity of 55 feet per second at time t is equal to 0. For t is between 0 and 18 seconds, the car's acceleration, a of t, in feet per second squared, is the piecewise defined by the graph given. So what we're looking at right now is the graph of acceleration. Is the velocity of the car increasing at t is equal to 2 seconds? And justify. So velocity will be increasing if a of t is greater than 0, since a of t is the derivative of velocity. And remember that to find if a function is increasing or decreasing depends on the sign of the derivative. So we're going to look at 2, and we see that at a point 2, my acceleration is 15, which is a positive number. So we would say, yes, the velocity is increasing. And the reason would be because a of 2 is greater than 0. Now for B, over what interval is the velocity of the car decreasing? Velocity is decreasing when acceleration is negative. So that means that we're looking at when the graph is below the x-axis. So this particular interval here is where it starts to go below up to here. So from 6 to 16, because a of t is less than 0. Now, what is the velocity of the car at the end of the 18 seconds? So what this means is that we are looking for v of 18. Because this is acceleration and we're looking for the velocity at a particular time, that means that we're going to have to integrate. Now, when we integrate, right, we need our limits of integration. I only have this 18. But it does tell me here in the question that the velocity is 55 feet per second at time t is equal to 0. So what that means here is that v of 0 is 55. So these are like those questions we've done before. Our limits of integration would be these two values of t. So from 0 to 18 of v of t dt, of a of t dt, is going to equal to v of t evaluated from 0 to 18. to get this number, this is, like I said, what we've been doing before. We need to find the area here. Now, a couple of things that I notice. I have a trapezoid here above my x-axis. So I'm going across the whole time. This trapezoid here can actually cancel out with this trapezoid here. See, here we have a base of 3, base 1, base 3, base 1, and the height for each of these trapezoids is 3. So these would cancel. So I can pretty much ignore that. Then I also have this triangle up here, right? You see how the base is 1 and the height is 3. I have another triangle here, base 1 and height of 3, that would also cancel. So the only area I need to calculate to get this integral would be this particular rectangle, which is 3 times 1. So 3 times 1 is 3, and that's going to equal to v of 18 minus v of 0. Now I know that v of 0 is 55. So we have this equation, 3 equals to v of 18 minus 55. So I'm going to add 55 to both sides, and I get that v of 18 is equal to 58. And my units, because it says velocity, is feet per second. And that's basically a review of a lot of things that we've done with particle motion and adding on to it using the fundamental theorem of calculus.